Every equation in physics can be written without reference to you. The Schrödinger equation governs quantum development. Einstein's field equations describe the curvature of space-time. Maxwell's equations describe electromagnetism. The Standard Model Lagrangian encodes every known particle and every known force. None of these contains a term for awareness. None contains a variable for experience. None predicts that matter, arranged in certain configurations, should feel anything at all. Your consciousness, the inner experience of reading these words, hearing this voice, seeing whatever you see right now, violates the known laws of physics. Not because it contradicts them, because it exists outside them entirely. The laws describe a universe of matter, energy, fields, and forces. You are matter in motion. You are also aware. The laws account for the first fact. They are silent on the second. This is the hard problem of consciousness, named in 1995 by philosopher David Chalmers. By the end of this video, you will understand this fundamental puzzle and why no physical theory addresses it. You will examine the leading scientific theories and see where each one fails. You will confront the philosophical arguments that expose the gap between matter and mind. And you will follow the evidence to its rational conclusion. If you find value in explorations like this, in understanding the deep puzzles that keep physicists awake at night, consider subscribing to the channel, which helps these deep dives reach more curious minds. Now, let us begin. You are the most certain thing in the universe. Not the stars, not the equations, not the measurements confirmed to 12 decimal places. You. The fact that you are conscious, that there is something it is like to be you, right now, in this moment, is the one piece of knowledge you possess that cannot be doubted, cannot be revised, cannot be overturned by future experiments. René Descartes recognized this in 1649. Cogito ergo sum. I think, therefore I am. Everything else, the external world, the reliability of your senses, the accuracy of your memories, can, in principle, be questioned. Your consciousness cannot. It is the foundation, it is the starting point, and it does not appear anywhere in the equations that describe the physical universe. The hard problem of consciousness was given its name in 1995 by the philosopher David Chalmers, born 1966, New Zealand-born, now at New York University. Chalmers distinguished between the easy problems and the hard problem. The easy problems are functional. How does the brain process sensory information? How does it integrate data from different senses? How does it control behavior? How does it report on its own states? These problems are hard in the engineering sense. They require decades of research, sophisticated instruments, extraordinary effort, but they are tractable. They ask how the brain does things. The hard problem asks something categorically different. Why does any of this processing feel like anything? Consider the distinction carefully, because everything in this video depends on understanding it. When light enters your eye, photons strike the retina, approximately 126 million photoreceptor cells packed into a surface smaller than a postage stamp. Each photoreceptor converts light into electrochemical signals. The signals travel through the optic nerve, approximately 1.2 million fibers, each carrying pulses at speeds of up to 120 meters per second, approximately 270 miles per hour, to the visual cortex at the back of the brain. Neurons fire, patterns form, information is processed. The brain distinguishes colors, edges, shapes, motion, depth. All of this can, in principle, be described by physics and neuroscience, by equations governing ion channels, neurotransmitter release, synaptic potentials, and electromagnetic field propagation. The easy problems are about describing this machinery. The hard problem is about something else entirely. Why does the machinery produce an inner experience? Why does the color red look red to you? Not, why does the brain classify wavelengths? That is an easy problem. Why does the classification feel like something? Why does pain hurt? Not, why does the brain avoid tissue damage? That is an easy problem. Why does the avoidance feel like suffering? Why does music move you? Not, why does the brain process acoustic frequencies? That is an easy problem. Why does the processing feel like beauty? Why is there something it is like to be you rather than nothing? Think about this through an analogy. Picture a piano. You can describe every physical aspect of the instrument: the spruce soundboard, the cast iron frame, the 230 steel strings, the 88 hammers wrapped in compressed felt. You can describe the mechanics of how pressing a key lifts a hammer that strikes a string that vibrates at a specific frequency, middle C at 261.63 Hz. You can measure the sound waves, their amplitude, their harmonics, their decay rate. You can write equations for every step of the process, from the force of the pianist's finger, approximately 50 grams for a pianissimo, approximately 250 grams for a fortissimo, to the vibration of the air molecules, to the deflection of the listener's eardrum. None of these descriptions tells you why the sound of a Chopin nocturne is beautiful. None tells you why it produces a feeling, a specific, qualitative, subjective feeling in the listener. The beauty is not in the equations. The feeling is not in the physics. The experience is not in the mechanism. This is the hard problem. The mechanism is necessary for the experience. Without the piano, there is no sound. Without the brain, there is no conscious experience. Necessity is not sufficiency. The mechanism does not explain the experience. The physics does not predict the qualia. Chalmers stated the problem with precision. Even with a complete physical description of the brain, whether the creature is conscious seems unanswered. A complete description, every neuron, every synapse, every ion channel, every electromagnetic field, every quantum state, tells you everything about the structure, the chemistry, the dynamics, the information processing. It does not tell you whether the creature has an inner life. It does not tell you whether there is something it is like to be that creature. The question remains open, not because we lack data, but because the data is the wrong kind. Physical data describes objective properties. Consciousness is subjective. The gap between them is not empirical, it is logical. What does it mean that the most confirmed equations in the history of physics, equations that predict the behavior of matter to 12 decimal places, that have withstood a century of experimental testing without a single failure, contain no term for the one thing each of us knows with absolute certainty, that we are conscious. The gap is not new. It has been recognized in different forms for as long as humans have reflected on the nature of mind. Descartes, in the 17th century, separated mind from body, arguing that the thinking substance, res cogitans, and the extended substance, res extensa, are fundamentally different. The body occupies space, the mind does not. The body is measurable, the mind is not. Descartes could not explain how the two interact, and neither can modern science, despite 4 centuries of progress. The instruments have improved beyond anything Descartes could have imagined. From Hans Berger's first human EEG recording in 1924, detecting alpha waves, approximately 8 to 13 Hertz oscillations in the brain's electrical activity, discovered at the University of Jena in Germany, to modern functional MRI that can localize brain activity to cubic millimeters, to optogenetics that can activate specific neuron populations with light, to the Human Connectome project, launched in 2013, that has mapped the brain's wiring at unprecedented resolution. The instruments have mapped the neural correlates of consciousness with extraordinary precision. They have not closed the gap between the physical and the experiential. The gap is where Descartes left it, between the measurable and the felt. Consider what this reveals. 4 centuries of scientific progress, from Descartes' dualism through Berger's EEG, through modern optogenetics, have not narrowed the explanatory gap between brain and mind. The materialist will respond. The gap is a gap in our knowledge, not a gap in reality. Future science will close it. But consider what closing the gap would require. It would require deriving subjective experience from objective properties, deriving what it feels like from what it does. It would require showing that the equations of physics logically entail consciousness, that any universe governed by these equations must contain conscious beings. No one has shown this. No one has come close. The philosophical zombie argument, which we will examine shortly, suggests it may be logically impossible. If a physically identical being without consciousness is conceivable, then consciousness is not logically entailed by the physics. The gap is not empirical, it is logical. Think of another analogy. Picture a master cartographer who has mapped every feature of a continent, every mountain, every river, every forest, every city, every road, every elevation contour. The map is complete. It is accurate. It is the finest map ever produced. The cartographer shows the map to a traveller and says, "This is the continent." The traveller responds, "The map shows me what the continent looks like from above. It does not show me what it feels like to stand on the summit of that mountain, to swim in that river, to walk through that forest." The map describes the territory. It does not contain the experience of the territory. Neuroscience is the cartographer. The brain is the continent. The map is exquisite. The experience is not in the map. Thomas Nagel, born 1937, American philosopher at New York University, made this vivid in his 1974 essay, "What is it like to be a bat?" Nagel argued that even if we knew every physical fact about a bat, every detail of its sonar, its wing membranes, its neural architecture, the frequencies of its echolocation pulses, approximately 20 to 200 kilohertz, far above human hearing, we would still not know what it is like to be a bat. The subjective experience of echolocation, the felt quality of navigating by sound in total darkness, of perceiving the world through reflected ultrasonic pulses rather than through light, is not captured by any third-person description. You can describe the bat's brain down to the last synapse. You cannot experience the bat's world. The knowledge is categorically different. Think of it this way through a second analogy. A colorblind neuroscientist, call her Mary, could know everything about the physics of color. That red light has a wavelength of approximately 620 to 750 nanometers, that the human retina contains approximately 6 million cone cells sensitive to different wavelength ranges, S cones for short wavelengths, M cones for medium, L cones for long, that the signals are processed through opponent channels in the lateral geniculate nucleus and decoded by color-selective neurons in area V4 of the visual cortex. Mary could write every equation, draw every diagram, trace every signal from retina to cortex. Mary would still not know what red looks like. This is Frank Jackson's Mary's Room argument, 1982. Mary, raised in a black and white room, knows all the physical facts about color vision. When she leaves the room and sees red for the first time, she learns something new, something that was not contained in her complete physical knowledge. She gains knowledge of qualia, of subjective experience. If all knowledge were physical knowledge, Mary would have nothing new to learn. She does learn something, therefore not all knowledge is physical. What does it mean that a complete physical description of the brain, every neuron mapped, every connection traced, every equation solved, does not predict whether the brain is conscious? Let us now examine the equations themselves, the fundamental laws of physics, and confirm that consciousness is absent from every one of them. The Schrödinger equation, I(h bar d psi over dt equals h hat psi. This equation governs the quantum development of every particle in the universe. I is the imaginary unit, the square root of -1. H bar is the reduced Planck constant, approximately 1.055 times 10 to the -34 joule seconds, a number so small it governs only the microscopic world. Psi is the wave function, the mathematical object that encodes the complete quantum state of a system, determining the probability of every possible measurement outcome. H hat is the Hamiltonian, the operator encoding the system's total energy. The equation is deterministic, linear, and complete within its domain. It describes how quantum states evolve over time with mathematical certainty. The equation contains no variable for awareness. It contains no operator for experience. It would operate identically in a universe of philosophical zombies, beings physically identical to us but with no inner experience, as in our universe. The Schrödinger equation does not know that consciousness exists. It does not predict consciousness. It does not require consciousness. Erwin Schrödinger wrote it in 1926, And in the centuries since, no physicist has found a way to derive conscious experience from its formalism. The equation describes what matter does. It is silent about what matter feels. Einstein's field equations. G sub mu nu plus lambda G sub mu nu equals 8 pi G over c to the fourth times T sub mu nu. These are the equations of general relativity, the most successful theory of gravity ever devised. G sub mu nu is the Einstein tensor, encoding the curvature of space-time. Lambda is the cosmological constant, the energy density of the vacuum, approximately 10 to the negative 122 in Planck units, the most extreme fine-tuning in all of physics. G sub mu nu is the metric tensor, defining distances and angles in curved space-time. T sub mu nu is the stress-energy tensor, encoding the distribution of matter and energy. G is Newton's gravitational constant. C is the speed of light. Einstein published these equations in 1915. They predict gravitational waves, ripples in space-time caused by the acceleration of massive objects. The Laser Interferometer Gravitational Wave Observatory, LIGO, with detectors in Livingston, Louisiana and Hanford, Washington, confirmed this prediction on September 14, 2015, detecting the gravitational waves from two black holes merging approximately 1.3 billion light-years away. The signal matched Einstein's equations to extraordinary precision. The equations predict black holes, regions of space-time where gravity is so intense that nothing, not even light, can escape. The Event Horizon Telescope, a network of radio telescopes spanning the globe, produced the first direct image of a black hole's shadow in M87 on April 10, 2019. A glowing ring of superheated gas surrounding a dark void, 55 million light-years from Earth, with a mass of approximately 6.5 billion suns. The image matched the equations. The James Webb Space Telescope, launched in 2021, has since observed the most distant galaxies ever seen, their light travelling for over 13 billion years, confirming that even at these cosmic extremes, Einstein's equations govern the curvature of space-time with perfect accuracy. The equations do not predict consciousness. They do not contain consciousness. A universe described entirely by Einstein's field equations is a universe of curved space-time and flowing energy, a universe of geometry and matter, not a universe of experience. The cosmological constant lambda, 10 to the negative 122, is fine-tuned to a degree that permits galaxies, stars, planets, chemistry, and ultimately conscious beings to exist. The equations describe the stage on which consciousness appears. They do not describe the actor. Maxwell's equations, 4 equations describing electromagnetism, first unified by James Clerk Maxwell in the 1860s, govern every electrical signal in your brain. Gauss's law, the divergence of the electric field equals the charge density divided by the permittivity of free space. Faraday's law, a changing magnetic field produces an electric field. Ampère-Maxwell law, a changing electric field produces a magnetic field. Gauss's law for magnetism. there are no magnetic monopoles. These equations describe how neurons communicate through electrochemical signals propagating along axons at speeds of approximately 120 meters per second, approximately 270 miles per hour, generating small electromagnetic fields that can be detected by EEG electrodes placed on the scalp. The equations are impersonal. They describe fields and charges with mathematical precision. They would produce exactly the same electromagnetic fields in a zombie brain as in a conscious brain, because the zombie, by definition, is physically identical. The electromagnetic field in your visual cortex when you see red is physically describable by Maxwell's equations. The experience of seeing red is not. What does it mean that the equations governing your brain, the equations describing every electrical signal, every chemical reaction, every quantum transition in your neurons, are exactly the same equations that would govern a brain with no inner experience at all? This is not a gap in our knowledge that future science might fill. It is a gap in the structure of physics itself. The equations are complete within their domain. They describe matter and energy with extraordinary precision. They do not describe mind. They do not predict mind. They do not entail mind. Think about the analogy of an accounting ledger. A perfect ledger records every financial transaction in a business, every dollar earned, every dollar spent, every asset, every liability, every depreciation, every tax payment. The ledger is complete. It is accurate. It contains all the financial information. It does not contain the purpose of the business. It does not contain the satisfaction of the workers. It does not contain the loyalty of the customers. The ledger describes one dimension of reality, the financial dimension, and is silent about other dimensions. Physics is the universe's ledger. It records every transaction of matter and energy with extraordinary precision. It is silent about experience. It is silent about you. This brings us to the leading scientific theories of consciousness, and to the specific, documented ways in which each one fails to bridge the gap between matter and mind. Integrated Information Theory, IIT, was proposed by Giulio Tononi, born 1959, Italian neuroscientist at the University of Wisconsin-Madison, beginning in 2004, and has been developed through multiple versions, IIT 2.0, 3.0 and 4.0, with collaborators including Christoph Koch, born 1956, German-American neuroscientist and prominent consciousness researcher. IIT is the most mathematically ambitious theory of consciousness in current science. It proposes that consciousness is identical to integrated information, quantified by a measure called phi. Conceptually, phi measures the amount of information generated by a system as a whole, above and beyond the information generated by its parts. The higher a system's phi, the more conscious it is. IIT starts from axioms about experience, that consciousness is intrinsic, structured, specific, unified, and definite, and derives postulates about the physical substrate that should support consciousness. IIT is bold. It attempts to do what no other theory does: put consciousness into a mathematical framework. Phi is proposed as the quantity that measures consciousness, a number, in principle computable, that tells you how conscious a system is. If IIT were correct, consciousness would be as measurable as temperature or pressure. The theory would close the explanatory gap by identifying consciousness with a physical quantity. Think of this analogy. Picture an architect who claims to have designed a building that converts electricity into happiness. The blueprint is detailed, the equations are precise, the structural calculations are sound. The building is built, electricity flows through it. The architect measures the current, the voltage, the power distribution. Everything matches the blueprint. The architect declares, the building produces happiness. The question is, does it? How would you know? Happiness is not a current, it is not a voltage, it is not measurable by the instruments that measure electricity. IIT faces the same challenge. Phi is computable, in principle, from the physical structure of a system. Phi measures integrated information. Consciousness, the theory claims, is identical to Phi. The claim connects a measurable quantity to a subjective quality. But the connection is an assertion, not a derivation. It is a bold metaphysical claim dressed in mathematical language. The prosecution. IIT has faced both theoretical and experimental challenges. Theoretically, Adam Barrett and colleagues noted in a 2025 analysis that IIT operates with discrete logic units, gates and neurons, binary states, digital architectures, whereas the standard model of physics uses continuous fields, quantum fields filling all of space, with values at every point, governed by differential equations. The two mathematical frameworks are fundamentally different. To reconcile IIT with the physics that actually governs the matter in the brain, a reformulation in terms of continuous fields would be needed, and no such reformulation exists. IIT is not integrated into physics. It sits alongside physics, making claims about consciousness that the physics does not support, does not derive, and does not contain. IIT's phi is not a term in any physical equation. It is an additional quantity, defined outside the standard model, with no physical mechanism connecting it to the subjective experience it claims to measure. Experimentally, the challenge is direct and recent. In 2025, a landmark adversarial collaboration, a pre-registered experiment designed by proponents of both IIT and global neuronal workspace theory, GNWT, agreed upon in advance, with specific predictions from each theory documented before any data was collected, published results in Nature by the Cogitate Consortium. This matters. The experiment was not designed by critics to attack the theories. It was designed by the theories' own proponents to test their predictions against each other. The experiment used invasive intracranial EEG recordings, electrodes placed directly on the brain's surface, in human subjects performing visual tasks. The subjects viewed images under conditions that isolated conscious perception from unconscious processing. The results challenged key predictions of IIT. IIT predicted sustained cortical synchrony, ongoing coordinated neural activity in posterior brain regions during conscious perception. The data did not show this. The expected synchrony did not materialize in the predicted form. The results, as the authors stated, align with some predictions of both theories but challenge others, and challenges extend to other theories as well. What does it mean when the most mathematically rigorous theory of consciousness, the theory that attempted to put mind into an equation, is challenged by its own pre-registered experimental test? What does it mean when the theory's own proponents designed the experiment, agreed on the predictions, collected the data, and found the predictions did not hold? Picture another analogy. A structural engineer certifies a bridge's foundation. Years later, cracks appear. An investigation is launched. The engineer is asked to re-examine the foundation using the same methods that were used to certify it. The engineer's own inspection finds problems. This is not an adversary discovering a flaw. This is the certifier discovering a flaw using the certifier's own tools. The 2025 adversarial test is the equivalent. IIT's own proponents participated in designing the test that challenged IIT's predictions. To be fair to IIT, the theory has produced one clinically useful tool, the Perturbational Complexity Index, PCI, a measure derived from TMSEEG responses, transcranial magnetic stimulation combined with electroencephalography. PCI effectively distinguishes conscious states from unconscious states. It is high when a person is awake and aware, low when under anesthesia or in a coma, and intermediate in cases of minimal consciousness, including some patients previously diagnosed as vegetative who, it turns out, retain islands of awareness. PCI is a correlation tool. It measures the complexity of the brain's response to a magnetic pulse. It does not measure consciousness itself. It measures something that tracks with consciousness, much as a fever thermometer tracks with infection without measuring the pathogen. The distinction matters. PCI tells you whether a brain is probably conscious. It does not tell you why. IIT also implies panpsychism, the view that consciousness is a fundamental property of all matter. If phi is greater than 0 for any system with integrated information, and even a thermostat has some degree of integrated information, then even simple systems have some minimal degree of consciousness. Even an electron, even a rock. Proponents of panpsychism, such as the philosopher Philip Goff, argue that this is a feature, not a bug. If consciousness cannot emerge from non-conscious matter, as the hard problem suggests, then perhaps consciousness was there all along, distributed throughout nature in tiny quantities, combining in complex systems to produce the rich experience of human awareness. The prosecution. Panpsychism is a retreat, not an explanation. It does not reduce consciousness to physics. It adds consciousness to physics, placing it alongside mass, charge, and spin as a fundamental property. It does not explain how micro-experiences combine into macro-experiences, the combination problem. How do the proto-experiences of trillions of atoms assemble into the unified experience of seeing a sunset? No mechanism is provided, no equation is offered. The combination problem is, in many respects, as hard as the hard problem itself. It merely relocates the mystery from how does consciousness emerge from non-consciousness to how do tiny consciousnesses merge into big consciousness. The mystery is preserved, the vocabulary is changed. Think of this analogy. Picture a chef who is asked to explain how a soufflé rises. The chef responds, "Each egg already contains a tiny soufflé. When you combine many eggs, the tiny soufflés merge into a large soufflé." The explanation is circular. It replaces one mystery, how eggs become a soufflé, with another, how tiny soufflés merge. Panpsychism does the same with consciousness. John Searle, born 1932, American philosopher at the University of California, Berkeley, has offered a different perspective through his Chinese room thought experiment, 1980. Imagine a person in a room who does not understand Chinese. The person receives Chinese characters through a slot, consults a rule book, and produces appropriate Chinese responses. From outside, the room appears to understand Chinese. From inside, the person understands nothing, merely manipulating symbols according to rules. Searle's argument, computation, symbol manipulation according to rules, is not sufficient for understanding, and therefore not sufficient for consciousness. A computer that perfectly simulates a brain would process information, produce outputs, pass every functional test, and might understand nothing. It might be a zombie. Searle's own position, biological naturalism, holds that consciousness is caused by brain processes, is real, is irreducible, and cannot be captured by current physics. Searle acknowledges the gap. He insists consciousness is not an illusion. He provides no mechanism for how the brain produces experience. His contribution is diagnostic. He identifies the problem with clarity and refuses to dissolve it with philosophical sleight of hand. Global Neuronal Workspace Theory, GNWT, was proposed by Bernard Baars, born 1937, American cognitive scientist, in 1988, and developed extensively by Stanislas Dehaene, born 1965, French neuroscientist at the Collège de France, and colleagues. GNWT uses a metaphor that Baars described: the theatre of consciousness. Unconscious processes are the audience in the dark. Conscious content is what appears on the illuminated stage, visible to all, available for processing by multiple cognitive systems simultaneously. Think of GNWT through the analogy of a newsroom. Information arrives from many sources: foreign correspondence, wire services, social media feeds, government press releases, investigative reporters, weather stations. Most of it stays on individual desks, processed by specialist editors. The editor-in-chief selects one story to broadcast on the main screen, the screen visible to every desk, every camera operator, every producer. The moment the story hits the main screen, it becomes global, available to all systems simultaneously. GNWT proposes that consciousness is this moment of global broadcasting. when neural information crosses a threshold of activation and is broadcast across a network of interconnected brain regions, primarily prefrontal and parietal cortex. It becomes conscious. The analogy is useful. It describes a real phenomenon in the brain, the transition from unconscious processing to conscious awareness. Often involves a sudden, widespread activation, what Dehaene calls ignition, detectable by fMRI and EEG as a burst of coordinated activity in frontal and parietal regions, occurring approximately 300 milliseconds after stimulus presentation. The analogy is also the problem. A newsroom broadcast is not conscious. A computer network that broadcasts information globally is not conscious. An emergency alert system that sends a message to every phone in a city is not conscious. The function of broadcasting does not entail the experience of awareness. GNWT describes what consciousness does. It makes information globally available for decision-making, memory formation, and verbal report. GNWT does not explain what consciousness is, why global availability feels like anything, why the broadcast produces an inner movie, why the information on the main screen is accompanied by subjective experience. Think of the analogy of a thermostat. A thermostat senses temperature. It compares the sensed temperature to a set point. It activates heating or cooling. It integrates information from a sensor and broadcasts a decision to an actuator. It processes information, makes decisions, and controls behavior. It is not conscious. GNWT must explain why a brain that broadcasts information is conscious, while a thermostat that broadcasts decisions is not. And GNWT cannot, because the theory describes the cognitive architecture of consciousness, the broadcasting, not the ontological nature of consciousness, the experience. The 2025 adversarial test by the Cogitate Consortium challenged GNWT as well. GNWT predicted that conscious perception would be accompanied by a strong ignition, a sudden, sustained activation in prefrontal cortex at the onset of consciousness and possibly at stimulus offset. The data showed some ignition-like activity, but not the sustained prefrontal activation GNWT predicted as its signature. The prefrontal ignition was weaker and less consistent than the theory required. What does it mean that the two leading scientific theories of consciousness, the two theories considered serious enough to justify a pre-registered adversarial test published in Nature, both had key predictions challenged by the same data? I return to this point often, not because it is comfortable, because it is revealing. IIT attempted to derive consciousness from integrated information. The experiment challenged the derivation. GNWT attempted to identify consciousness with global broadcasting. The experiment challenged the identification. Neither theory was confirmed. Neither was conclusively refuted. Both were wounded. The hard problem remains standing, untouched by either. Orchestrated objective reduction, Orch OR, was proposed by Roger Penrose, born 1931, British mathematical physicist, Nobel Prize 2020 for his work on black holes and general relativity. And Stuart Hameroff, born 1947, American anesthesiologist at the University of Arizona in 1994. Orch OR takes a radically different approach from IIT and GNWT. Where those theories try to explain consciousness within existing physics, or with minor additions, Orch OR proposes that consciousness requires entirely new physics. Physics beyond the Standard Model, beyond quantum mechanics as currently understood, beyond anything that has been experimentally confirmed. Penrose's argument begins with mathematics. In his 1989 book, The Emperor's New Mind, Penrose argued, drawing on Kurt Gödel's incompleteness theorems, that human mathematical understanding involves non-computable processes. Processes that no Turing machine, no computer, however powerful, can simulate. If the brain performs non-computable operations, then consciousness cannot be reduced to computation, and no computational theory of consciousness, including IIT and GNWT, can be complete. Consciousness, Penrose argued, requires a new physical mechanism. Hameroff proposed the mechanism: quantum computations in microtubules, protein structures approximately 25 nanometers in diameter that form the internal skeleton of every cell, including neurons. In Orch OR, the brain's microtubules maintain quantum coherence, superpositions of tubulin protein states, and these superpositions undergo objective reduction, collapse, when a gravitational threshold is reached. Each collapse is a moment of consciousness. The collapses are orchestrated by the neural architecture, producing coherent conscious experiences rather than random noise. Think of this analogy. Picture a cell phone tower broadcasting a signal. The tower has antennas, amplifiers, processors, all operating with classical electronics. Now imagine someone claiming that the real content of the broadcast, the meaning, the semantic information, is not in the radio waves, but in the quantum vibrations of individual metal atoms in the antenna's copper wiring. The claim would require evidence that quantum effects in the copper atoms influence the broadcast in ways that classical electronics do not. Without that evidence, the claim is speculation. Orch OR makes an analogous claim. The real consciousness is not in the neural firing patterns, the classical broadcast, but in the quantum vibrations of tubulin proteins inside the neurons, the antenna atoms. The claim requires evidence that quantum effects in microtubules influence consciousness in ways that classical neural computation does not. The prosecution. The evidence is not there, and the physics works against it. Max Tegmark, Swedish-American physicist at MIT, calculated in 2000 the decoherence times for quantum superpositions at the scale of neural microtubules at body temperature, approximately 37 degrees Celsius, approximately 98.6 degrees Fahrenheit, are approximately 10 to the negative 13 seconds. That is 1/10 of 1/trillionth of a second. Neural processes operate on timescales of milliseconds, 10 to the negative 3 seconds. The quantum coherence required by Orch OR would be destroyed by thermal noise approximately 10 billion times faster than neurons can use it. The brain is approximately 310 Kelvin. Quantum coherence at 310 Kelvin in a wet, chemically active, electromagnetically noisy environment like the interior of a neuron is, by the calculations, physically untenable. Hameroff has responded by proposing that microtubules maintain quantum coherence through special biological shielding, that the protein structure somehow insulates the quantum states from the thermal environment. No experimental evidence supports this claim. The burden of proof is on the claimant, and the claim contradicts the best available calculations. What does it mean that the most ambitious attempt to explain consciousness through new physics, through quantum gravity operating in the brain's protein structures, requires quantum coherence lasting 10 billion times longer than the physics permits? Now let us examine the materialist position itself, the default assumption, the background framework, the philosophy that most working neuroscientists accept without examination. The materialist position holds that consciousness is just brain activity. Proponents of materialism argue that neurons firing in certain patterns produce subjective experience. The brain has approximately 86 billion neurons, each with an average of approximately 7,000 synaptic connections, forming a network of approximately 100 trillion synapses, 10 to the 14 connections. The network consumes approximately 20 watts of power, roughly equivalent to a dim light bulb, which is approximately 20% of the body's total energy expenditure, despite the brain constituting only approximately 2% of body weight, approximately 1.3 to 1.4 kilograms, approximately 3 pounds. The complexity is sufficient, materialists argue, for consciousness to emerge the way wetness emerges from water molecules, the way temperature emerges from molecular motion. No extra ingredient is needed. Consciousness is what complex brains do. The cross-examination, the analogy to wetness, is the most common and the most revealing, because it fails precisely where it needs to succeed. Wetness is a macroscopic description of molecular behavior. It is fully reducible to the physics of hydrogen bonds, surface tension, and molecular adhesion. There is no hard problem of wetness. If you understand the molecular physics completely, the geometry of H2O, the polarity of the oxygen-hydrogen bond, the angle of 104.5 degrees, the resulting dipole moment, you understand wetness completely. No residual mystery remains. No further fact is needed. No philosopher loses sleep over the explanatory gap between H2O molecules and wetness. There is no gap. Consciousness is categorically different. Understanding the neural physics completely, every ion channel, every synaptic vesicle, every neurotransmitter molecule, every electromagnetic field generated by every neuron, does not yield an understanding of why the neural activity feels like anything. The gap is not between our current knowledge and future knowledge. It is between objective description and subjective experience, between the third person and the first person, between it and I. Picture two identical computers running the same program, same hardware, same software, same inputs, same outputs. Both process the same information, produce the same results, execute the same operations. Now imagine that one is conscious. It has an inner experience of what it is computing, a felt sense of processing data. And the other is not. It is a zombie computer, functionally identical, experientially empty. This is the philosophical zombie thought experiment, formalized by Chalmers in 1996. If a zombie is conceivable, if you can imagine a being physically identical to you, but with no consciousness, then physical properties alone do not logically entail consciousness. Something more is needed, something that the physics does not contain. The conceivability of zombies is debated among professional philosophers. A 2013 survey found that approximately 36% of philosophers considered zombies conceivable, while approximately 24% considered them metaphysically possible. The numbers matter less than the debate itself. If even a notable minority of experts in the philosophy of mind consider it possible that a complete physical duplicate of a human could lack consciousness, then consciousness is not a straightforward consequence of the physical laws. It is not forced by the equations. It is not entailed by the physics. It is something extra, something that the Standard Model, general relativity, quantum mechanics, and Maxwell's equations do not generate. The prosecution. Materialism does not explain consciousness. It assumes consciousness. It asserts that sufficiently complex arrangements of matter become conscious. But it provides no mechanism for the transition, no equation for the threshold, no prediction of when or how or why the crossing occurs. At what point does complexity generate experience? At 86 billion neurons? At 50 billion? At 10 billion? At 1 billion? At a million? Is a fruit fly conscious? Is a thermostat? Is a rock? Materialism offers no principled answer, because it has no theory of the transition from non-conscious matter to conscious experience. It has correlations. It has the neural correlates of consciousness, the specific brain activity patterns associated with specific conscious experiences, mapped by decades of fMRI, EEG, single neuron recording, and invasive electrode studies. Correlation is not explanation. Correlation identifies what happens alongside consciousness. It does not explain why consciousness happens at all. Think of this through a forensic analogy. A detective investigates a crime. The crime scene is rich with evidence: fingerprints on the glass, DNA on the handle, footprints in the mud, security footage of the suspect entering at 11:47 p.m. The detective correlates every piece of evidence with the suspect. The correlation is overwhelming. Every data point aligns. The detective announces, "The case is solved." A colleague asks, "But how was the crime committed? What was the sequence of events? What was the mechanism?" The detective pauses. The detective has the correlations, every neural correlate of the crime scene. The detective does not have the explanation, the mechanism by which the crime occurred. Neuroscience is in this position with consciousness. The fingerprints are everywhere. The mechanism is unknown. What does it mean that the most successful scientific framework in history, a framework that can predict the mass of the electron to 12 decimal places, detect gravitational waves from black holes 1.3 billion light-years away, image the shadow of a supermassive black hole in Messier 87, cannot explain the one thing you know most directly, that you are aware. The Blue Brain Project, a computational neuroscience initiative launched in 2005 at the École Polytechnique Fédérale de Lausanne in Switzerland, has attempted to simulate portions of the mammalian brain at the cellular level. The project has modelled millions of neurons and their synaptic connections, replicating the firing patterns observed in biological brains with extraordinary fidelity. The simulations process information. They produce outputs consistent with neural dynamics. They exhibit patterns that match experimental recordings from living tissue. They are not conscious. No simulation, however detailed, however faithful, however computationally expensive, has produced anything that anyone, anywhere, has identified as subjective experience. The machinery runs. The inner movie does not play. The ledger balances. The accountant is not home. Benjamin Libet, born 1916, died 2007, American neuroscientist at the University of California, San Francisco, performed a landmark experiment in 1983 that exposed the timing relationship between brain activity and conscious experience. Libet asked subjects to flex their wrist at a spontaneously chosen moment and to note the position of a clock hand when they first became aware of the urge to flex. Simultaneously, he recorded the readiness potential, a build-up of electrical activity in the supplementary motor area of the cortex that precedes voluntary movement. The result? The readiness potential began approximately 550 milliseconds before the wrist flexed. The subjects reported becoming aware of the urge approximately 200 milliseconds before the movement. The brain's preparation preceded the conscious awareness of deciding by approximately 350 milliseconds. The neural machinery was preparing the movement more than a third of a second before the person was aware of intending to move. Think about what this means through an analogy. Picture a CEO who believes she runs the company. She makes decisions. She signs documents. She issues directives. Then, an audit reveals that every decision she made was prepared by her staff 350 milliseconds before she became aware of it. The staff prepared the memo, drafted the directive, cued it for her signature. She signed. She believed she decided. She was informed after the machinery had already committed. Libet's experiment suggests a similar relationship between the brain's neural machinery and the conscious I that believes it is deciding. The experiment does not prove consciousness is causally inert. Libet himself noted that subjects could veto the prepared movement in the final 100 to 200 milliseconds before execution, suggesting that conscious will, while not initiating action, might have the power to inhibit it. The debate continues. The data are clear. The neural preparation for a voluntary decision begins before the subject is consciously aware of deciding. What does it mean that the brain begins preparing a movement before the person is consciously aware of choosing to make it? Split brain studies, pioneered by Roger Sperry, born 1913, died 1994, American neuropsychologist, Nobel Prize 1981, and his student Michael Gazzaniga in the 1960s, revealed something even more unsettling about the relationship between brain structure and conscious experience. When the corpus callosum, the thick bundle of approximately 200 million nerve fibers connecting the brain's two hemispheres, is surgically severed, a procedure performed to treat severe epilepsy, the patient's two hemispheres behave as if they contain two separate conscious agents. Each hemisphere can process information independently. The left hemisphere, which controls the right hand and, in most people, language, can name objects, reason verbally, and make articulate decisions. The right hemisphere, which controls the left hand and specializes in spatial processing, facial recognition, and emotion, cannot speak, but it can guide the left hand to point at objects, draw pictures, and make independent choices. In one famous case, a split brain patient was shown the word walk to the right hemisphere and a different word to the left. The patient stood up and began walking, but when asked why, the left hemisphere, which had not seen walk, confabulated an explanation. "I wanted to get a drink of water." The left hemisphere did not know the real reason. It made one up and believed it. What does it mean that cutting a bundle of nerve fibers can apparently divide a single conscious being into two, each with its own perception, its own preferences, its own decisions, its own confabulations? These experimental findings, from Libet, from Sperry, from the adversarial collaboration, from the Blue Brain Project, converge on a single conclusion that the materialist framework cannot accommodate. The relationship between brain activity and consciousness is not the relationship between mechanism and product. It is the relationship between correlation and mystery. The brain correlates with consciousness. The brain does not explain consciousness. Daniel Dennett, born 1942, died 2024, American philosopher at Tufts University, represented the most radical materialist response to the hard problem: deny it exists. In his 1991 book, Consciousness Explained, Dennett argued that the hard problem is a pseudo-problem, that consciousness, as described by Chalmers, subjective experience, qualia, the inner movie, is an illusion generated by the brain's information processing architecture. There is no inner theatre. There is no audience watching the show. There is only the processing, and the processing creates the false impression that there is something it is like to experience. Think of this through an analogy. A magician performs a card trick. The audience is amazed. Dennett's position is equivalent to the magician saying, "There is no trick. There is no magic. Your experience of being amazed is itself the trick, and it does not really exist." The audience responds, "We are amazed. We experience amazement. Telling us the amazement does not exist does not make it disappear. It makes the explanation less credible than the experience." The prosecution. Dennett's position is self-defeating. If consciousness is an illusion, who is experiencing the illusion? An illusion requires a subject who is deceived. If there is no subject, no inner experiencer, no I, then there is no one to be deceived, and the concept of illusion collapses. The claim that consciousness is an illusion presupposes the consciousness it denies. It is the philosophical equivalent of sawing off the branch you are sitting on. If consciousness is an illusion, then Dennett's own argument, the reasoning he presents, the conclusions he draws, the words he chooses, is itself the product of an illusory process. If subjective experience does not exist, then the subjective experience of following an argument, evaluating evidence, and reaching a conclusion does not exist either. Dennett's own philosophy undermines its own epistemic foundations. It is, as Chalmers observed, not a solution to the hard problem. It is a denial that the problem exists. A denial that fails precisely because the denial itself is a conscious act. This brings us to the evolutionary account of consciousness, and to the specific way in which it fails to answer the hard problem. The defense. Proponents of the evolutionary account argue that consciousness conferred a survival advantage, that organisms with inner experience could model their environment more effectively, anticipate threats, simulate future scenarios, and coordinate complex social behaviors. Consciousness, in this view, is a biological adaptation, as natural as wings for flight, eyes for sight, legs for locomotion. The cross-examination. The evolutionary account explains why brains became more complex over time. It explains why information processing became more sophisticated. It does not explain why information processing became conscious. Consider this analogy. A security system can detect intruders, sound alarms, record footage, distinguish between a cat and a burglar, notify the police, and adapt its sensitivity based on time of day. It processes information. It responds to threats. It integrates multiple data streams. It makes decisions. It does not experience anything. It has no inner life, no felt sense of detecting the intruder, no subjective experience of sounding the alarm. A sufficiently advanced security system could model its environment, predict threats, adapt its behavior, learn from mistakes, all without a single moment of consciousness. If unconscious information processing can perform every survival-relevant function, then consciousness provides no survival advantage that unconscious processing does not also provide. And if consciousness provides no additional survival advantage, natural selection cannot explain why it exists. The prosecution. The theory of evolution, as proposed, claims that biological complexity arises through unguided processes, random genetic mutations filtered by natural selection over vast timescales. The theory describes how bodies change over time. The theory describes how brains grow larger and more connected. The theory does not describe how matter begins to feel. The origin of the first flicker of subjective experience, the first moment in the history of life when physical processes were accompanied by an inner awareness, however dim, however primitive, has no evolutionary explanation. Wings can be explained by selection for flight, eyes by selection for photosensitivity, legs by selection for locomotion. Consciousness cannot be explained by selection for any function, because every function consciousness performs could, in principle, be performed without consciousness. The zombie argument applies directly. If a zombie organism could survive and reproduce as effectively as a conscious organism, and there is no principled reason why it could not, then natural selection would not prefer consciousness over zombiehood. Consciousness would be invisible to selection. It would be a free rider, present but unexplained. The gap is not between simple consciousness and complex consciousness. It is between no consciousness and any consciousness at all. The first appearance of subjective experience in the history of the universe is the hardest version of the hard problem, and no evolutionary account addresses it. Francis Crick, born 1916, died 2004, British molecular biologist, co-discoverer of DNA's double helix structure, Nobel Prize 1962, stated, "The origin of life appears at the moment to be almost a miracle. So many are the conditions which would have had to be satisfied to get it going." If the origin of life itself strains naturalistic explanation, the origin of consciousness, a phenomenon even more difficult to account for, even less understood, even further from any mechanistic derivation, strains it to the point of breaking. What does it mean that the theory invoked to explain all biological complexity, the theory that claims to account for every feature of every living organism, cannot explain the origin of the one feature that makes biological creatures fundamentally different from machines? The problem deepens when we consider the specific qualities of human consciousness, qualities that distinguish human minds not merely in degree, but in kind from anything else in the observed universe. Moral consciousness. Every human society in recorded history, without exception, has distinguished between good and evil. The specific rules vary, the categories do not. Murder is wrong. Protecting the helpless is right. Betrayal deserves punishment. Sacrifice deserves honor. Some philosophers argue that morality is subjective, that it is culturally constructed, that it is an evolutionary adaptation for social cohesion. The prosecution. No one lives as though morality is subjective. The philosopher who argues that morality is a social construct still experiences moral outrage when betrayed. The evolutionary psychologist who claims that moral intuitions are survival mechanisms still condemns genocide as objectively evil, not merely as a culturally disfavored behavior. Moral outrage presupposes an objective standard. Without an objective standard, condemning any practice, slavery, torture, cruelty, is merely expressing a preference, no different from preferring chocolate over vanilla. The existence of genuine moral knowledge, knowledge that some things are truly good and some things are truly evil, regardless of cultural context, requires a foundation beyond human opinion. If morality is objective, it cannot be grounded in subjective matter. If morality is real, it points beyond the physical to a moral source, to an intelligent cause that embedded moral awareness into conscious beings. Self-awareness. You are not merely conscious, you are conscious of being conscious. You can reflect on your own thoughts, evaluate your own reasoning, question your own motives, contemplate your own mortality. No other known creature does this. No equation predicts it. No physical law requires it. The capacity for self-reference, for thinking about thinking, for knowing that you know, creates a recursive structure that no computational model has successfully captured. Think of a camera pointed at its own screen. The image contains the image, contains the image, receding into infinity. Self-awareness is the mind's camera pointed at itself. The recursion is real. The experience of the recursion is undeniable. The physics has no account of it. The awareness of mortality. Every human knows that they will die. This knowledge, unique in the animal kingdom as far as we can observe, produces existential reflection, religious inquiry, philosophical examination, and the search for meaning that has characterized every human civilization. If consciousness were merely an evolutionary adaptation for survival, awareness of mortality would be maladaptive. It produces anxiety, fear, and paralyzing dread. Natural selection, according to the evolutionary account, should have eliminated it. It did not. Every human carries the awareness of death. Every civilization has responded to it with rituals, beliefs, and narratives about what lies beyond. The near-universal human intuition of continued existence after death, present in every civilization, in every era, across every cultural boundary, may point to something real rather than a universal delusion. Some materialists argue that death is the end, that consciousness ceases when the brain ceases to function. The prosecution: this is an assertion, not a conclusion from evidence. No experiment has measured what happens to consciousness at the moment of death. No instrument has detected the cessation of subjective experience. The claim that death is the end is a deduction from materialist premises. If consciousness is just brain activity, then brain death ends consciousness. The deduction is valid only if the premise is true. And the premise that consciousness is just brain activity is precisely what the hard problem shows to be unproven. The sense of I, the persistent, unified awareness that observes your thoughts, perceives the world, maintains continuity through time, is what many traditions have called the soul. The materialist claim holds that there is no soul, only neurons. The prosecution: the subjective experience of I cannot be located in any neuron, any synaptic connection, any neural network. You can damage specific brain regions and lose specific functions, language, motor control, visual processing, memory. But as long as any awareness persists, the I persists. The sense of being a subject, an experiencer, a witness, is not identical to any particular brain function. It is the condition for all brain function to be experienced. What we call the soul may be what makes consciousness possible, the non-physical ground of subjective experience that the equations do not predict and the neuroscience does not explain. The fine-tuning of the universe's physical constants connects directly to the consciousness question, because the constants determine whether conscious beings can exist at all. The cosmological constant, lambda, approximately 10 to the negative 122 in Planck units. If lambda were significantly larger, even by a factor of 100, the universe would have expanded too rapidly for galaxies, stars, planets, and chemistry to form. No structure, no complexity, no life, no consciousness. If lambda were negative and of comparable magnitude, the universe would have recollapsed within millions of years. No time for evolution, no time for anything. The fine structure constant, alpha, approximately 1/137.036, determines the strength of the electromagnetic interaction between charged particles. Change alpha by approximately 4% in either direction, and molecular chemistry collapses. No stable molecules, no proteins, no DNA, no neurons, no brains, no consciousness. The Oklo natural nuclear reactor, a natural fission reactor that operated approximately 1.7 billion years ago in what is now Gabon, West Africa, discovered by French scientists in 1972, constrains any variation in alpha to less than 1 part in 10 million over 1.7 billion years. The electromagnetic constant has been fine-tuned and stable for at least a third of the age of the universe. The strong nuclear force, if approximately 2% weaker, protons and neutrons would not bind into nuclei. No elements beyond hydrogen, no carbon, no oxygen, no biochemistry. If approximately 0.5% stronger, all hydrogen would fuse into helium in the early universe. No hydrogen, no water, no stars burning hydrogen for billions of years, no stable, long-lived energy sources. Stephen Hawking stated, "The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life." Paul Davies, secular physicist, summarized, "There is now broad agreement among physicists and cosmologists that the universe is, in several respects, fine-tuned for life." Martin Rees, Astronomer Royal, former president of the Royal Society, identified 6 dimensionless constants, whose values must lie in narrow ranges for stars, chemistry, and observers to exist. Fred Hoyle, upon discovering that carbon nucleosynthesis in stars requires a specific nuclear resonance, the Hoyle state at approximately 7.65 mega-electron volts, stated, "A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics as well as with chemistry and biology." Picture a combination lock with 26 dials. Each dial runs from 0 to 1,000,000,000,000. The lock opens only when all 26 are set to specific values, not approximately, exactly. The probability of random chance producing the correct combination is a number with no useful analogy in human experience. What makes this stranger than any combination lock? The dials were not set by anyone turning them. They appear to have come preset from the beginning of time. What does it mean that 26 independent physical constants all fall within the narrow ranges required for conscious beings to exist, and that none of them is derived from any deeper theory? None is predicted by any equation. Each is simply measured and accepted as a brute fact. Some cosmologists propose the multiverse, an infinite ensemble of universes with different constants. We observe life-friendly values, they argue, because only life-friendly values permit observers. The anthropic principle applied to an infinite landscape. The prosecution. The multiverse has 0 observational evidence. No other universe has been observed, measured, detected, or interacted with. The theory is unfalsifiable. No possible observation could disprove it, because the other universes are causally disconnected from ours. By the standards of the scientific method, observation, experimentation, falsifiability, the multiverse is not science. It is philosophical speculation deployed to avoid the implications of fine-tuning. Even if infinite universes existed, the mechanism generating them would require its own explanation, its own laws, its own parameters, its own fine-tuning. The multiverse does not eliminate the need for a cause, it multiplies it. The Borde-Guth-Vilenkin theorem, 2003, establishes that any space-time region with average expansion rate greater than 0 is past incomplete. It had a beginning. Even the multiverse, if it exists, began. Even the landscape requires a landscaper. Some argue that given enough time, anything can happen, that the improbability of fine-tuning and consciousness is mitigated by the sheer scale of the cosmos or the duration of its existence. The prosecution, probability does not work this way. Some events are not merely improbable, they are categorically excluded by the structure of the possibility space. An infinite number of monkeys typing on an infinite number of typewriters for an infinite duration will produce every finite sequence of characters, but they will not produce a coherent novel, because coherence is not a property that random processes generate. Time does not make the impossible probable. It makes the improbable inevitable only when the event is within the possibility space, and consciousness is not within the possibility space of known physics. The equations do not predict it. The laws do not generate it. No amount of time changes this. Science will eventually explain it. This claim, heard whenever the hard problem is raised, whenever fine-tuning is acknowledged, whenever the limits of materialism are exposed, is not an argument. It is faith. Faith in future discoveries deployed to avoid a present conclusion. Some questions are not scientific questions. Science describes how the universe operates within a framework of laws and constants. Science cannot explain why the framework exists, why there is something rather than nothing, why unconscious matter produces conscious experience. These are metaphysical questions. They lie outside the domain of empirical measurement. They require metaphysical answers. Using "science will explain it eventually" to defer the conclusion is no more rational than the God of the gaps accusation that materialists level at theists. The difference is, the evidence for an intelligent cause is present now, in the fine-tuning, in the hard problem, in the failure of every naturalistic theory of consciousness. The evidence for a naturalistic explanation of consciousness is absent now, absent after 3 decades of the hard problem, absent after the 2025 adversarial test, absent despite billions of dollars in neuroscience research. This is the second part that stays with me. Not the failure of individual theories. Theories fail all the time, and new ones replace them. The persistence of the gap. The hard problem was named in 1995. It was identified in substance centuries earlier. 3 decades of modern neuroscience, fMRI, EEG, MEG, PET, optogenetics, single neuron recording, computational modeling, the Human Connectome Project, 2013, DARPA-funded whole brain simulations have produced extraordinary maps of the brain's structure and function. None of this has narrowed the gap. The gap is where it was in 1995. The gap is where it was in 1974, when Nagel asked what it is like to be a bat. The gap is where it was in 1649, when Descartes separated mind from body. Something has always existed. If there were ever truly nothing, absolute nothing, with no matter, no energy, no fields, no laws, no potential, no mathematical structures, no capacity of any kind, then nothing would exist now. Nothing has no mechanism. Nothing has no tendency. Nothing has no creative power. 0 plus 0 equals 0, always, permanently, without exception. The universe exists. Stars burn. Galaxies recede. Consciousness observes. Something has always existed. The universe itself has not always existed. The Big Bang, confirmed by the cosmic microwave background, detected by Arno Penzias and Robert Wilson at Bell Labs in 1965, mapped by COBE in 1992, WMAP in 2003, and the Planck satellite in 2018, by the observed expansion, measured by Edwin Hubble in 1929, confirmed as accelerating by Saul Perlmutter, Brian Schmidt and Adam Rees in 1998, by primordial nucleosynthesis, and by the Borde-Guth-Vilenkin theorem, 2003, establishes a finite past. The universe had a beginning. Whatever caused the universe must be external to it, external to time, which began with the universe, external to space, which began with the expansion, external to the laws of physics, which govern the universe's contents, not its origin. The evidence demands specific attributes of this cause. Power, sufficient to bring into existence a universe with approximately 10 to the 80 particles, 4 fundamental forces, hundreds of subatomic particles, governed by equations of extraordinary mathematical precision. Equations that predict gravitational waves, permit nuclear fusion, generate the periodic table of elements, and sustain the chemistry of life. Knowledge, sufficient to configure the physical constants within the narrow life-permitting ranges, alpha at 1 over 137, lambda at 10 to the negative 122, the strong force tuned to 2%, the proton-to-electron mass ratio at 1836.15, within approximately 0.1% of the critical value for chemistry. The Higgs mass in the electroweak stability window. The configuration was selected from among an enormous space of alternatives. Selection from alternatives requires knowledge of the alternatives and their consequences. Will, because a specific configuration was chosen. The constants could have been different. The laws could have been different. The initial conditions could have been different. They are what they are because something selected them. Selection from alternatives is an act. Acts require agents. Agents that select possess will. These attributes, power, knowledge, will, are not theological inventions. They are logical deductions from the evidence. They are the attributes of an intelligent cause, eternal, uncaused, distinct from the creation, that configured the universe with the precision required for conscious beings to arise. The consciousness argument completes the case. Unconscious matter does not produce consciousness. No equation predicts it. No theory derives it. No experiment generates it. No simulation reproduces it. The hard problem remains unsolved, not because science has not tried, not because funding has been insufficient, not because the instruments are too crude, but because the problem may be categorically beyond the scope of physical science. The equations describe matter. Consciousness is not matter. The equations describe energy. Consciousness is not energy. The equations describe fields. Consciousness is not a field. Consciousness is something that the equations do not generate, do not predict, and do not contain. The quantum measurement problem, which has haunted physics since the 1930s, is relevant here. In 1961, the physicist Eugene Wigner proposed a thought experiment, Wigner's friend, in which an observer inside a laboratory performs a quantum measurement, obtaining a definite result, while an observer outside the laboratory describes the entire lab, including the friend, as still being in a quantum superposition. The thought experiment raises the question: does the friend's conscious observation collapse the wave function, or does the superposition persist until Wigner himself observes? In 2019, researchers led by Massimiliano Proietti at Heriot-Watt University in Edinburgh experimentally realized a version of the Wigner's friend scenario with entangled photons, and found that two observers can arrive at contradictory conclusions about whether a measurement has occurred, depending on their perspective. The results suggest that the role of the observer in quantum mechanics is not settled, and that consciousness may occupy a position in physics that the current formalism cannot accommodate. The measurement problem does not prove that consciousness is fundamental. It reveals that physics itself has not determined whether consciousness is inside or outside the equations, a gap that the materialist framework has no tools to close. If consciousness is not derived from physics, it must come from beyond physics. If the known laws do not predict it, something outside the known laws must account for it. If matter alone does not produce mind, something non-material must be involved. The evidence does not name this something with religious specificity. The evidence describes its attributes with logical precision. Power sufficient to create a universe, knowledge sufficient to configure its constants, will sufficient to select the specific configuration that permits consciousness. An intelligent cause. Eternal. Uncaused. Distinct from the physical universe it brought into existence. The universality of theistic intuition is itself evidence. Dr. Justin Barrett, cognitive scientist at Oxford University, conducted studies involving children from more than 20 countries, including atheistic societies such as China and Japan, and found that children independently arrive at belief in a higher being without being taught. The belief is not culturally imposed. It is innate. Every civilization in human history, without exception, has believed in some form of higher power. Mass atheism is a modern Western anomaly, an exception to the universal pattern, not the rule. Every innate, universal human belief, causality, logic, self-awareness, turns out to correspond to something real. The universal belief in an intelligent cause behind the cosmos may be another such correspondence. Not a delusion, but a recognition. Not an invention, but a discovery. The chain of causes must terminate. An infinite regress of dependent causes, each requiring a prior cause, stretching backward without limit, would never reach the present. If every cause required a prior cause, the chain would have no beginning, and without a beginning, no subsequent event could occur. The fact that we are here, conscious, aware, capable of examining the equations and recognizing that they do not predict our existence, proves the chain terminates at something uncaused, something eternal, something self-sufficient, something with the power, knowledge, and will the evidence demands. Something that is not matter, not energy, not a field, because matter, energy, and fields had a beginning, and this cause is their origin, not their product. What does it mean that you exist as a conscious being in a universe whose equations do not predict consciousness? What does it mean that the constants are fine-tuned for conscious life, and that the leading theories of consciousness have failed their own experimental tests? What does it mean that the most familiar fact you know, that you are aware, is the one fact the entire edifice of physics cannot explain? It means the evidence points one direction, not to blind chance, not to purposeless mechanism, not to an eternal regression of unconscious causes producing conscious beings by accident, to an intelligent cause with power, knowledge, and will that brought the universe into existence, configured its constants with the precision required for conscious life, and endowed conscious beings with the awareness to examine the evidence and reach this conclusion. Let me bring this exploration to a close. We began with the observation that no equation in physics contains a term for consciousness. We examined the Schrödinger equation, Einstein's field equations, and Maxwell's equations, the equations that govern quantum mechanics, gravity, and electromagnetism, and confirmed that each describes matter and energy with extraordinary precision, and none predicts, contains, or entails subjective experience. We examined the hard problem of consciousness, David Chalmers' formulation of the logical gap between physical processes and conscious experience, the gap between it and I. We examined Thomas Nagel's bat, the argument that knowing every physical fact about a creature does not tell you what it is like to be that creature. We examined Frank Jackson's Mary, the argument that a complete physical description of color does not contain the experience of seeing color. We examined the philosophical zombie, the argument that if a physical duplicate without consciousness is conceivable, then physics does not logically entail consciousness. We examined the leading scientific theories. Integrated information theory, Giulio Tononi's attempt to put consciousness into an equation, challenged by its own pre-registered adversarial test in 2025, and by the fundamental mismatch between IIT's discrete logic framework and the continuous fields of real physics. Global neuronal workspace theory, Bernard Baar's and Stanislas Dehaene's model of consciousness as information broadcasting, challenged by the same 2025 test, which found weaker prefrontal ignition than the theory predicted, and fundamentally unable to explain why broadcasting produces experience. Orchestrated objective reduction, Roger Penrose and Stuart Hameroff's quantum mind theory, undermined by Max Tegmark's calculation that decoherence times in neural tissue are 10 billion times shorter than neural processing timescales, forcing quantum coherence at body temperature that the physics does not permit. We examined the materialist claim that consciousness is just brain activity, and showed that it assumes what it claims to explain. The Blue Brain project simulates millions of neurons without producing consciousness. Libet's 1983 experiment reveals that neural preparation precedes conscious awareness by 350 milliseconds. Sperry's split brain studies show that severing the corpus callosum can apparently divide a single consciousness into two. The neural correlates of consciousness are well documented. The mechanism by which neural activity becomes conscious experience is unknown. We examined the evolutionary account and showed that it explains why brains became complex, not why complexity became conscious. We showed that consciousness provides no survival advantage that unconscious processing does not also provide, and therefore natural selection cannot explain its origin. We examined the fine-tuning of physical constants, the cosmological constant at 10 to the negative 122, the fine structure constant at 1 over 137, the strong force tuned to 2%, the proton to electron mass ratio at 1836.15, and showed that secular scientists like Hawking, Davis, Rees and Hoyle acknowledged the precision as extraordinary and unexplained. We examined the multiverse. Zero evidence, unfalsifiable, shifts the fine-tuning problem rather than solving it. We examined, given enough time, anything can happen, and showed it confuses improbability with impossibility. We examined, science will explain it eventually, and showed it is faith deployed as argument, a promissory note with no collateral. Every line of evidence converges on the same conclusion. Consciousness is not predicted by physics. It is not explained by neuroscience. It is not accounted for by any scientific theory. Not IIT, not GNWT, not Orch OR, not materialism, not evolutionary psychology. The constants are fine-tuned for conscious life. The leading theories have been challenged by their own experimental tests. The hard problem remains standing, as it has for 3 decades, as it has for centuries, untouched by the most intensive period of brain research in human history. The evidence points to an intelligent cause, eternal, uncaused, possessing power, knowledge, and will, that configured the universe for conscious life and endowed conscious beings with the awareness to examine the evidence. That is not faith against evidence. That is the conclusion the evidence demands when followed honestly to its logical end without evasion. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. Sleep well tonight, conscious, aware, experiencing the quiet of the evening In a universe whose equations predict the trajectory of every particle, but cannot explain why any of it feels like anything. Your consciousness violates the known laws of physics. The laws describe matter in motion. You are more than matter in motion. The equations confirm it by their silence. The hard problem confirms it by its persistence. The fine-tuning confirms it by its precision. And the question of what accounts for the difference between a universe of blind mechanism and a universe that contains you, aware, thinking, wondering, has an answer the evidence provides. The evidence points one direction. It has pointed there throughout this entire examination. It points toward an intelligent cause, with power, knowledge and will, that stands behind the equations, behind the constants, behind the laws, behind the consciousness that the laws cannot explain. Good night.